Hello, ladies and gentlemen. Welcome to my channel. This is Mr. Arias, and my math channel is Math to the Point. In today's class, we're going to investigate how to find the equation of a quadratic function in vertex form if all we have is its graph on a coordinate plane. So in this problem, we have that the graph of the function g of x is here on the coordinate plane, which is in blue, and that happens to be a translation of the mother function f of x is equal to x to the power of 2. Just to recap, this function here is the function that we're calling the mother function, or the parent function, or the father function, because any other quadratic function in existence comes from this basic function. So like they say here, this is a variation of the shape in the graph of the mother function x to the power of 2. Okay? So I'm going to quickly tell you the fastest way to get this problem done. So our goal and our objective in this problem is to find out this equation, which is a times x minus h to the power of 2 plus k. And for this to happen, we have to determine the values of a, h, and k. So step one will be the following. Compare the graph in the locations of the vertices of the mother function or the parent function and the function g of x in this problem. So I'm going to quickly draw a quick sketch of the parent function, which is the function that has its vertex at the origin. So this sketch, I apologize, it's going to be pretty much not perfect at all, but you will get the point that this function has its lowest point at the origin, which is the point 0, 0. So that's my vertex right here, right? And now I'm going to compare this location of the vertex of the mother function with the location of the vertex of the function g of x. So if you notice, the lowest point of this graph, g of x, is located here at the point 9, comma, -3. So those are the two different locations that we have, 0, 0 for the vertex of the mother function, x to the power of 2, and then we have the coordinates 9, comma, -3 for the function g of x, whose equation we have to find. Now, your question in your head at this moment should be the following. How can I get from the vertex of the mother function to the vertex of the function g of x? So we have to basically move around the coordinate plane to get to the second location. And the question is, how much or by how many units do we have to translate this vertex across the x-axis to get to this point? And the answer is basically 9. So I have to drag this point, this vertex, from the origin 9 units to the right-hand side across the x-axis, and then from here I would have to go down 3 units. Okay, and because I'm going down, that represents a negative quantity. So that would be -3. And those, ladies and gentlemen, represent the values of h and k. H is always this value that determines the horizontal translation across the x-axis. If you're moving to the right, that's a positive value. If you're moving to the left, that's a negative value. In this case, my h is +9. On the other hand, because k determines the vertical shift across the y-axis, because in this case, we have to go down to get to the location of the second vertex, that value of k will be represented by a negative integer. Okay, and then as you can see, I already found the value of h and k. The only thing we have to determine would be the value of a. And again, in this problem, as you can see, we have the same opening, which is a situation in which the functions are opening up like this. And also because in this problem, they're not really mentioning anything about any compression or stretch, you can safely assume that the value of a is going to be between, it's going to be basically either +1 or -1. If it's +1, the function will be opening up like the mother function, which is the case in this problem. And then if it is -1, it'll be opening down, which is not the case in this problem. So technically speaking, the last comment is that the value of a is equal to +1, just like in the mother function. And these problems tell you specifically if you have to take into account any value of a that's not equal to +1 or -1. There will be a comment saying, hey, this function is being stretched by this factor, or it's being compressed by this other factor. If they don't mention that, you can safely say that it's going to be either +1 or -1. Now, the last comment is to replace, we have to replace the values of a, h, and k into my equation in vertex form, and that will be the final answer, which I'll put right here. So we have the equation, which is g of x is equal to a, which in this case is +1. So we replace that a with +1. We open the parentheses, replace the x, which doesn't change. It's a variable that is going to be staying like this in the equation. Then we have the mandatory negative symbol between the x and the value of h. And then we replace that h with +9. Lastly, we add by the value of k, which is -3. Then we end up having this semi-perfect final answer. But the last thing we have to kind of play with is this minus and plus and minus that we have in the parentheses and outside the parentheses. So anytime that you have a plus and a minus symbol next to each other, they reduce just down to a minus symbol. And that'll be the final answer. Okay, so basically g of x will turn out to be 1 times x minus 9 and then -3. And we have the power of 2 in this parentheses. So this is the equation that determines this shape in blue of the function g of x. I hope this video helps. Thank you for watching this lesson and have a wonderful day. I'll talk to you soon, ladies and gentlemen. Take care.